Okay, today is lesson 2.2, and it's actually day 2 of that. We're talking about the Mad Mouse Lab, which is basically a little project where you use your calculator and you're learning about how to enter functions that are piecewise functions. It might be, for instance, a straight line in this little area, a parabola in this little area, and a square root in that little area, and get it all set up so that it does exactly what you want, which in this case, this is important. You don't have to just try to make this picture. You have to do what it says. The track is at point A is 30 meters high. It has to be at 30 meters high right there. Now, I'm going to give you something that I think would make your life a lot easier, and that is tell you what I'd recommend for these spots here. Okay, now we just need something at fairly regular intervals, right? But if I count by ones, do you get my graph would be incredibly dinky? Okay, so let's count by fives. So let's just make this 5, 10, 15, and 20. Now you could have made this, 25 and 30 if you wanted to make the parabola part wider or something, but this would work. Okay, now by doing that, do you get, I really told you a point right here instead of just saying 30 feet? What is that point? What comma what? 5 comma 30. Okay. And how about this point right here? 10 comma 10. Now, what if I asked you for the equation of a line that went through those 2 points? That sounds exactly like one of those top 20 skills that I've been reminding you about and saying those would be important. I think some of you still don't know how to do that, which means, oh, I guess you should have caught up by now, and I warned you. So I will remind you quick, but this is why if you're not willing to learn those top 20s, then you should run away, because you need to learn them to handle the rigor of this class. All right, so that's 2 points, and I can figure out the slope from that. Remember how to do the slope for it? And that's the rise over the run, right? The y2 minus the y1, so I go 10 minus the 30 makes negative 20 over 10 minus the 5 makes 5. And so what's the slope? Negative 4. That's how the steepness of that line right there. So now, what was wrong with my equation that we put in before? It didn't have the right slope, for one thing. Okay, and then I can even figure out the whole rest of the equation from this if you know not just the slope. If you know this equation, y minus y1 equals m times x minus x sub 1. That's one of those top 20 important skills. Here's a point, here's a point, here's the slope. And now I can go in and put in either one of these 2 points, and 10 comma 10 is definitely easier to put in because they're both 10s. I can put a 10 in here and a 10 in there, and then I know the slope, I already figured it out, is 4, or negative 4, sorry. And then I just have to solve for y, and I can put it into my equation. Now, I don't want to do all of that for you. You have to figure that out. But I just gave you a gigantor hint on how to get this equation. And it'll be perfect. I won't have to guess and check my way to doing it. Guessing and checking would take you a long time to get that line in the exact right spot. All right, so I did tell you it was negative 4. So I'm going to just put that part in here now. So I'm going to put in a negative, and then I should insert, oh, I just hit the wrong button. Try again. I should go over here one, and then insert, right on top of that spot, I want a 4. There we go, negative 4x plus 3, and plus 3 is clearly not near high enough, because when I actually graph this thing, can't even see it. Okay, so I'm going to go back and say negative 4 plus 3. Maybe I should move it up to like plus 30. And now I need to have that whole insert a divide. Now, why on earth am I dividing by this? Because again, as I tried to explain to my class before, this is our domain. And what the computer is going to read that as is a test. And if the x is in between 5 and 10, it will work and therefore give the answer of 1. So when you divide by 1, your calculator's happy. And if this is a test and the x fails the test, like you're trying to put in 0, it won't work and it'll give it a 0. And then you'll be dividing by 0 and it'll fake the function into not working there. All right, so this is how you would do your domains. If you include a divide and then a parenthesis with your truth statement in there, some of you are going to wonder, where did I get the and? Like any other function, you can get all the functions under the catalog button. So if I hit second catalog, and is right there, second thing down. Okay? So I didn't want to do the whole Mad Mouse project for you, but I wanted to get you started on thinking about how you could get that first line written. And I've got the slope right for you now. You just have to figure out exactly, what's wrong with this picture. Because right now, if I hit graph, that is not how it's supposed to look. Clearly, I should be moving this thing up. And for the next piece of the Mad Mouse, you'll have a different equation, of course. And pause for a second. Okay, so I should just minimize that. There is the first part, and if you get this thing moved up far enough, you'll be able to get it in the right position. Now, how will you know for sure if your line is in the right spot? If you hit trace on your calculator, the trace button, everybody try hitting trace once. If your little plus sign doesn't show up, it'll tell you the X and the Y where it is. Like watch when I move to the left. If my X is 4.09, I can't see the little plus. Why? Because it's at a spot that's undefined. I got to keep moving to the right until my X is in the range where I know it's going to be working. There we go. And so, can you tell right here that mine currently has a height of 10? That's not where I want it, is it? Where is it supposed to start again? At 30. So how much higher do I need to go? So if I add 20 to that, whatever I had, that might do it. All right. So I'd have to change my equation here. I'm going to let you do that part. Then this next part, just to clarify, it is an x squared. So I can put x squared, and then the little trick for doing the domain that I just learned from the internet, divide by, and then in parentheses, you're going to want to say your little zone. X is less than this, and x is greater than that, or again, I don't want to tell you the answers, but let's say I just wanted this to go between 10 and 15. So let's say I said x is greater than 10. I'll just say x is greater than 10 and let you figure out the rest. X is greater than is under the test menu, greater than 10. And I'll stop right there, even though I know there's more to it, but don't want to give away all the answers. So if I hit graph, how come I can't see my parabola? Where does the parabola want to be? Right there. Right? But I'm only allowing it to work after 10. So if you put in a 10, what would your parabola tell you? A lot higher than that, right? 10 squared is going to be 100. So anytime you can't see something, it probably has something to do with your window isn't far enough out. If something just isn't appearing, it's either that it's undefined there or it's just not far enough out. All right, so I'm going to go window. Tell me where, like, I want Y max to be more like, let's say 200. And I'll hit graph. Still can't see it. 10 squared, 10 times 10 is 100. Can't explain why that's not showing up right now. Okay. x is greater than 10. 10 squared should be 10 times 10 is 100. Or the first time it should show up is like 121. Well, I do know that I'm going to want to move my parabola to the right. So I'm going to try putting a parentheses around this and say x plus, I'm going to move it to the right how far? Maybe like 20 or so? That's left 20. Oops. It's minus 20 and the parentheses squared. There we go. Now let me see if it shows up. Yay, my parabola showed up. I had to move it over. Doesn't it make sense that I had to move it over? Think about it. The parabola is bottom, my parabola has got to be over here. How far should I have really moved it over, though? If I move it over 15, its base is going to be right there. And mine, I think it'd be 12 and a half. Yeah. All right. So this is going to take some guessing and checking. Do you remember me saying that I would allow you to work with a partner on this one? I absolutely will allow you to work with a partner on this one. So there is strength in numbers. So, and I got to insert the 0.5. If somebody can help you and go, oh, I think I figured out the parabola. And then I graph it. All right, now my parabola keeps going though, so I have to put an end limit on it. So right now it's going to go till infinity, anything bigger than 10. And this line, I'm going to get my window closer here. My x max is 35. Actually, I can still see everything. Maybe I should just leave it alone. Okay, so I guess moral of the story here is this is going to take a lot of guessing and checking until you get it right. I could have already gotten these tube in the right spot, but I'm trying not to tell you everything. And when it's all done, I had a kid walk up at the end of last hour, and they already had it looking right. Okay, so this is not going to take you forever. You got a parabola, you've got a square root function, and remember that square root function is moved over a long ways and then up. So square root of x, move to the right. Let's say I want to move to the right 12 spots, then I'm going to go minus 12. And then I want to move up like 10 spots, plus 10. Then you have a domain where it's got to be bigger than 15, I think. All right. Okay, so the rest of this job is yours. And last thought on this is how we're going to grade it. When you go to this is a key that helped me understand how this is meant to be. This is where you use words to describe what you did. Like, I took the square root function, and I had to move it to the right, and I had to move it up. That's words. The calculations is where you actually show the math, and then you say, well, my equation ended up being y equals, square root of x minus 15, and then I had to go up 10 or whatever, plus 10. And then I had to limit its domain, and so I put the domain of x had to be greater than or equal to 20 or whatever you're going to use there. Okay, conclusion. Oh, and the sketch with calculator means you can just copy what's on your calculator. Okay, so now one thing you may or may not have noticed is that on your parabola, you can make this wider than normal or narrower than normal. You can stretch it and make it like go deeper than this shows. It doesn't say how low the parabola has to go. You can flatten it out if that works for you and you want to make it like that. It doesn't say how that parabola has to look. It just has to connect up this spot and this spot. And that's going to be the hardest thing, is making them connect up right. Okay, now this Mad Mouse Lab thing is not due until Tuesday. So you got plenty of time to work on it. And the test is coming on Monday. So if you're prioritizing, shouldn't the test come before this? Definitely. Definitely. Okay, so let's move on. Everybody get to this slide. No, not that slide. We already did some of that yesterday. This slide right here, the one with the ducks in the row. And I'll pause for a second while you catch up and get to this slide right now, please. Would you please put your calculators away? I think you're just going to get distracted by trying to find the perfect answer. You can find that later. It is. Okay. Ready? So get to this spot with the ducks on the picture. I'm going to ask you to turn your iPad my way in about 10 seconds here, so hurry up. So on this slide, it's all about the order that you do it in. We're making a function. And so it's going to be g of x. And every function always has an x over there. Did you ever notice that? I shouldn't say that. It doesn't always have an x. You could have just a number like 5. If you have a number of 5, then you've got an equation where y is equal to 5. G of x is kind of like y. But to make these, since we're going to actually be putting things into them, we're going to have an x. Now we need to add 4 and multiply by 3. You get there's more than one way to do that? Now, there's only one way, though, to do it so that they happen in sequence, as in the first thing that has to happen is the add 4. Because, see, if I go like this, I go plus 4 and then multiply by 3 like this. Now, if I look back at my function and I see, did I do it right? Would the adding 4 happen first in this function? No, because it's got to multiply here. Math's picky that way. In this function, I'd have to multiply first, and that's not what they wanted. So I better rearrange this by putting in a parenthesis. I'm sure most of you knew that. That'll force the add 4 to be done first. Okay. Now, is this the right answer? Will that make it add 4 and then multiply by 3? Good. Then that's the answer. And now, instead of just giving you the function on this kind of problem, you have to make the function. And then you stick things into the function. So right now, would you stick 5 into the function? Easy as you might be thinking, 5 plus 4 is 9. 9 times the 3, 27. Raise your hand if you had 27 for that. Okay, good. And g of x, we already found it. It's right there. Okay. So here's another one that's just scarier looking. And it doesn't say to like add 5 and then multiply by 4. It says to multiply by c first and then add t. That's one of the things that makes the honors version of pre-calc harder than the regular one, because you have to be able to handle, just like I said, do it with a number. Now you got to be able to do it with a variable. So I know it changes from f of x to g of x. That just means the original function is f of x. The new one that you're creating goes right here. So would you please write down what you think the new function will be? We'll call it g of x. It started with an x to the third. And we have to multiply by c and add t. And what order do I want to do this one in? Times c, add t. Now we just look back at it and say, will this happen in the order I wanted? Will multiplying by c actually happen before the add? Yes, it will. Because if I was putting a number into this, I'd have to multiply it by c before I added, right? So that is the right order. Sure, c could be in front. Yeah. Multiply doesn't matter which way, right? 3 times 5 is the same as 5 times 3. All right, so yeah, that c could be in front of the x cubed too. That's the way I did it last hour. I just wanted to shake it up because I wanted people to see. I could do it in the exact order it says. First, multiply it by c times c, and then add t plus t. Sometimes the order they give it to you in, you can just write it down and it'll just flow naturally. And you always have to check, though. You have to look back and see, is this going to really do this first? And it would, because multiply comes before add. All right, so then just stick in a 5, and then down here, stick in a C, and when you're done with it, subtract T. That's the more complicated one. First, let's just put in a 5, and some people are going to be like, wait a minute, I don't know C and I don't know T. It's okay. You don't need to know them. You just write the answer with a C and a T in it. Would you check part A against the person sitting across from you? See if you got the same thing for part A. You stick in a 5 and get 125. 125C plus T, because that's what you should have had. How many had that right? Okay, good. Next up, G of C. Wait a minute, I'm supposed to put a C into the equation that already has a C in it? Yes, you are. Supposed to put a C in. So figure that out by sticking the C in, and then when you're done, you subtract T, and you'll get a simple, clean little answer. Compare that with the kid next to you also. Okay, so this one comes out to put the C in here, C to the 4th plus T, and then you subtract off the T, and then it's just C to the 4th. Okay, moving on. Let's go through. We already did a bunch of these before. I just want to remind you about one like that one. This is a domain question, and I'm reviewing it because this is one of the harder types of questions on your test that's coming up on Monday. People a lot of times forget that they're different. This part you want to set not equal to 0. This part you want to set greater than or equal to 0. Why the difference? Because this part needs to just stay positive, and it can be 0, because square root of 0 is not a problem, or the 4th root of 0 is not a problem. This part is saying if it turns into 0 on the bottom, it's going to crash the whole function. So the only thing we care about on the bottom is that it's not 0. So I'm going to solve these two equations. 2x plus 1 is greater than or equal to 0. Actually, you solve these two equations. X squared minus 1 not equal to 0. Remember, when you've got something squared, you're probably going to end up with 2 answers, so be careful. Then put it all on a number line and shade in the number line in the right spots. If I remember right, it looks something like this. But you have to figure it out. Okay, so here, subtract 1, 2x greater than or equal to negative 1, x greater than or equal to negative 1/2. Over here, add 1 to both sides, x squared not equal to 1. Square root of both sides. Don't forget, you get 2 answers. Absolute value of x is not equal to 1. 2 answers. X not equal to 1. X not equal to negative 1. So now I'll put that all together on one big number line. Here's negative 1. Here's negative 1/2. And here's positive 1. Those are all important spots. The 1 and the negative 1 can't work. The negative 1/2 does work. It says so right here. And now this is the important part. I'm supposed to shade to the right, and if you by accident shade right over the top of that empty spot, you're saying that this poisonous thing is now okay. It's okay for the top, but it would still crash the bottom. So you have to leave that poison spot alone. And there you go. There it is as a number line. Now, on the test, if it does not say how you are supposed to write your answer, I'm accepting number lines. I think they're the best way to see it visually, and we're kind of visual beings. So if you instead want to write this as negative 1/2, comma 1, parentheses, union with 1 to infinity, that would be good, especially if they said you need to put it in interval notation. Then you'd have to write it this way if it was going to be interval notation. Okay, so that's a little review. Trying to help you be ready. Okay, moving on. Oh, wait a minute. This one freaks people out because it's a fifth root, and you start getting like, what does that matter on a square root? Well, the ones that are even, like square roots or fourth roots, those cannot handle negatives, and therefore things will crash them. But third roots, you can get an answer. What's the cube root of 8? 2. What's the cube root of negative 8? Negative 2. It's no big deal. See how it doesn't crash when there's a negative underneath it? So, do I need to force this to stay positive? No, so I do not need to go through this whole, that's if it's a square root. For roots that are odd, they don't need that. Nothing's going to crash because you can't make that negative. Okay, so what if nothing crashes it? And what's the answer for the domain? Negative to positive infinity are all reals. Good. Okay. So this is just a reminder of what we've been doing with the Mad Mouse thing is really called piecewise functions. It's defined as this function when it's less than 0, and that function when x is bigger than 0. So it's two things. It's f of x equals x, or it's f of x equals x squared. And those are totally different functions. It's the one function on the left side of the graph, and it's the other function on the right side of the graph. Those are piecewise functions, and we talked about how to put those in the calculator or at length earlier on the Mad Mouse thing. All right, so here's another piecewise function. Now this one's a rocket launching. I want you to think for a moment. If the time's between 0 and 20 seconds, do you get the thing just took off and it's been in the air for 20 seconds? And then all of a sudden at 20 seconds, it changes to this function. Think in the context of a rocket launching. Why would it do that? Yes, sir. Okay. Yes, you could have it switching to a different engine. That's a pretty advanced model rocket, but that could happen. But what's here? What does that stand for? H of t. Height. The height is going to be this for the first 20 seconds and that for the rest of the time. Think about that. Yes?
That would be, bring us through those little lines on the axis, and that would actually...
Okay, so I'm talking more in context of this rocket. What is happening to said rocket? Yes? Good question, but this is not a real rocket that you can launch and keep up there forever. This is a model rocket. You don't launch them that high. Yes, sir? What? It hits the ground. Think about it. Its height is 0. What does that mean if its height is 0? It's on the ground. From 20 seconds on, it's on the ground. Does that make sense? It was in the air, and after 20 seconds or so, it's going to come back down again. Well, it depends on the amount of rocket. Maybe you could make one launch longer than that, but it's actually surprising how fast things will have to come down just based on gravity. You know, some people are like, I saw this guy jump and he was in the air for like 3 seconds. No, that would mean he had to jump like 45 feet high. That's impossible based on gravity. Okay, well, this thing is up there for 20 seconds, and then after, so let's talk about it. At h of t, what is that? Is that the height is 10? No, that's what? That's the height when what? At 10 seconds. What's this? Height at 60 seconds. I know the height at 60 seconds already, don't you? What's the height at 60 seconds? 0, because it's going to force it into this category, and therefore the answer is 0. And h of 10, that's in this little zone, so I got to actually go figure it out. Let's stick in a 10 into the equation to figure it out. Okay, what about h of t is 375? How do I do that? Where do I put the h of t? Sorry, what do I put into h of t? 375. So I put a 375 right there. You know, they're not that complicated. They give you an equation, and then you just have to figure out where to stick stuff in the equation. So if they give you the time, you're going to stick it in for t. They give you a height, you stick it in for h of t. So then, which one should I solve? 375 is equal to 0. That's kind of a dumb equation. So we don't need to bother solving that one. How about 375 is equal to that? Yes. Now this is something you can't just say, okay, so I'll solve that. Do you know how to solve that? What's the first step in any quadratic? If you can factor it, you should. Very good. But I can't factor this quite yet. Because before I start factoring it, I should set it to 0. In case you've forgotten this from higher algebra, you always got to get them equal to 0. There. Now that it's set equal to 0, I could factor it. Do you want to try to factor that one? That's going to be nasty. So what if you don't want to factor it? Quadratic formula. Very good. If you can't factor, quadratic formula. Repeat after me. If you can't factor, quadratic formula. If you can't factor, quadratic formula. Remember that. This is like a big thing you were supposed to learn in higher algebra last year. Is that if you can't factor the thing out, then you got to resort to the quadratic formula to solve it. There is one other option. If we allowed calculators, you could graph both sides and see where they cross. You could graph a line at y equals 375. A line with that would be a parabola, and you'd see where they touch. You can always solve equations that way, graphing both sides of an equation. Some people don't know this, and I didn't teach all of you before, so I'm just going to remind you. Say I was going to have this. I think we all know the answer is 5, right? X plus, or if I make the x a 5, it's going to work. 2 plus 5 is 7, right? But if you graph this, and you graph that, and you see where they cross, they will cross at 5. You can graph any equation that way. Graph both sides of it, see where they cross, you got your answer. Okay, so I can graph y equals 375 and y equals negative all that, and I see where they cross. That's probably just as easy, or easier maybe, than doing the whole quadratic formula. But if you haven't memorized the quadratic formula, that would be a problem. X equals negative b plus or minus square root b squared minus 4 ac all over 2a. Very nice. Okay, so your homework. Yesterday I had you skip the beginning and the end. We did the middle. Okay, so now I want you to go back, and the homework for tonight is do the beginning and the end. So basically the whole rest of the assignment. Now that is like 5 or 6 pages worth. The very last page says super challenge. It is just a challenge. You do not have to do the very last ones. You could spend an hour on them and maybe not figure them out. So consider that a challenge for you smarty pantses, and there are many in the crowd who might be challenged that nobody else can probably do this, but I could. All right. So number 1, let's start together here. And again, I know there's a bunch of problems, but this assignment was originally given last year in 1 day. The whole thing, including the middle part that we did yesterday. Okay, so it's reasonable that I've cut it into 2 days. That's doable. Last year I would have complained. Okay. Number 1, f is a function that takes a real number x and performs the following 3 steps in the order given. Oh yeah, it's this kind. So I say f of x is x, and now I'm going to have to multiply by 2. So I'm going to times it by 2, add 3, and divide by 4. I'll give you a hint. If I actually do this now, it won't do it in the right order. You can't just write them down like that. You got to look back at it and say, am I going to really be multiplying by 2 first? Yeah, I would. That part's good. Would I really be adding 3 next? Why would your calculator not actually add 3 next? Because it's going to do the divide by 4 next, because it knows that multiply and divide are tied in value, and therefore you go from left to right. So this is not going to work. You figure out how to fix it so that it will make it add 3 next, and then lastly divide by 4. Then you've got your function, and they don't even need you to stick anything in. That's going to come later on later problems. These first couple are just designing the function. All right, this is one where you stick things in, and I know you saw something like this before, but the problems were different than this. They were changed from this. Like this was 2x squared, I think. Yes, the last time we did it. So this is actually a little easier, but it's a good reminder. This stuff's on the test. I need you to practice this. Okay. And I think the answer key will actually have these answers, whereas the other ones that were changed, those answers weren't there. These answers are there. All right, this is stuff we did yesterday, and now we're on to this awesome problems. Okay, well, basically these are those graphs where you're supposed to be graphing between x is greater than or equal to 0. So from here on, I'm supposed to be graphing that. Well, if you're having trouble with these, remember what the base thing is. This is the parent function is 1 over x. Do you remember that 1 over x kind of looks like this? Okay, so the parent function is 1 over x, but it's been moved plus 1. What's that mean? Left 1. And I'm only supposed to do that graph for x is bigger than or equal to 0. All right, so here's my graph. Here's what it would normally have been. But I'm only supposed to do it for x is bigger than 0. So I can't do it over here on this side. And I'm supposed to move it where? Left 1. So I go, move it over to the left one. There we go. Okay. Now f of x is equal to a, and a is greater than 1. So any number bigger than 1 is what the answer is for this. Well, f of x is like y. Don't forget this is like y. It's like saying y is equal to any number bigger than 1. How can I graph that? Y is bigger than 1. Oh, here's the line where y is 1. And then they want it to be y is bigger than 1. Because a, see, y is a, and a is bigger than 1. A is bigger than 1 means I got a shade above that line. All right, I don't want to do your whole homework assignment for you, but they're doable. They're not super easy. This one is much, I believe, part B is easier than part A is. Just because you know what a parabola looks like more than you know what this parent function looks like. But maybe now that I've told you what 1 over x looks like, it won't be so bad. All right. Then there's some word problems. They're actually honestly easier than those graphs we were just talking about because they just give you an equation and you stick stuff in. Look, it says find v of 5. That just tells me to stick 5 into the function. V of x is this, and I just got to stick a 5 in there. That's not too bad. And then solve v of x is 27. Well, v of x is right here, so I put a 27 right there. And I figure out what x has to be. Those aren't too tough. Then it makes you think about why is x restricted to x is bigger than 0. If we're talking about the real world, there's a lot of situations where you can't have negatives. Think about it. In the real world, can you talk about how your baby is negative 2 inches long? No. So you're not going to have negatives in a lot of cases. Okay, and this one's again another equation, and all you have to do is answer the question. It says find h of 0. So they're just telling you to stick in a 0 for the time, the t, and then solve h of t equals 0. Whenever you have h of t equals 0, whenever you've got a 0 equals something with a parabola in it, you can either graph it or factor it. This one will factor, I think. 16 and the 64, they both have a 16 in them, so that'll work pretty well. That one will factor. 0 equals negative 16t squared plus 64. Because 16 can factor out of both of them, I bet you factoring it's all that the fastest. Or you can always use quadratic formula. There's A, there's C, and if there is no B, then what's B equal to? 0. Okay. All right, there's a little walkthrough of your homework. The super challengers are optional, and tomorrow's a review for the tests. Remember the Mad Mouse thing? If you like have some free time, just play with it. You can see how playing with it is kind of how you're going to end up getting those answers. Somebody already has got it. Nice. All right. And that's all I have for you for today.